minute. Oh, okay, we're going.
Okay.
All right. In a pie chart, why are the slices sectors different sizes? The third one?
Mm-hmm.
Okay. How are bar charts and Pareto charts related?
Only difference between a bar chart and a Pareto chart is that the ones on the P chart are ordered largest to smallest, going left to right.
Yep.
We conclude that P. What are you supposed to call that?
I have no idea.
I like to think of it as P with a dunce cap.
Stupid P. Oh, that's funny. Yeah, I don't know what to call it. Is it just the proportion?
Sure.
Okay.
Wait, is it the sample or the true proportion?
Yeah. True, I think. Right?
Yeah. And then regular P is, wait.
I thought silly P was the true proportion. Or am I wrong on that?
No, I think you're right. So P has to be the sample, regular P.
N is sample size, right?
Mm-hmm.
N is sample size, yep.
All right. If P equals 1/4, what is the smallest n that satisfies the requirement? Okay.
You tell us.
I put 1. But I don't know.
And I thought it was 4. Because if probability is, 1 in 4, then there needed to be 4 for there to be 1 of 4. But I may be completely wrong because I have no idea what I'm doing.
Oh no, that makes more sense than what I said.
And from this point on, I don't have a clue.
Jordan, do you have any thoughts?
On how to solve for what's the
On
smallest?
7.
The electrician doesn't know what's wrong.
I'm thinking about it. So n time. Well, if if P equals 1/4, so n time. Oh, let me pull out my calculator. So it's blank times 3/4 is greater than or equal to 10. So 10 divided by 0.75 is equal to 13.33. Right?
I thought that was only if we're trying to figure out if we can use the central limit theorem.
Say that again?
Because you just used NP is greater than or equal to 10, right?
Yeah.
But I thought that was just to figure out if the sample size was... okay, never mind.
What?
Oh, wait, but n times p is greater than 10 also. Oh, we did this stuff in calculus, and I'm just going to pretend like I forgot about that.
I've never done calculus. You're going to have to help me
I
out.
haven't either.
No, I mean, it's not. You just have to plug it in. So
yeah, you do use these two formulas, NP...
Those two formulas are the exact same thing, technically. Well, not the exact... Okay, no, not the exact same thing, but they're close.
Okay.
Hmm?
Because, you just take 1 minus p. Well, it tells you what p is. P is 1/4, right?
Right.
And so that's n times 0.75 is greater than or equal to 10. If that's the case, then it's 13.33 or 3/4. And then NP is greater than 10. If we're trying to figure out if it has to be the same thing for both, then it has to be 13.33. Yeah, I think it's 13.33. It might be 0.34, but I'm pretty sure it's 0.33.
Okay, that makes sense.
And this is for which one?
7.
7.
Yeah.
All right. I was looking at 8.
Okay, so what is the mean of silly p?
Silly. That's a good one.
See, this is where I'm confused because regular p represents the true population mean. And if silly p is the true population, then the mean is 0.4.
But it says round to the 10th place.
Right! Well, 0.4 is the 10th place.
Oh.
What do you guys think? Because it says right in the textbook that the true population mean is regular p.
Yeah, but I thought we determined that wasn't right when I said it earlier.
No, we determined it was right.
Oh.
Because it says the sample proportion, which is silly p, is normally, oh wait, hang on. Sample proportion. I think we got 5 wrong.
Yeah, I think you're right. I think that actually pointed it out.
Yeah. I think p is the true proportion. Because I just read it. It says sample proportion, which is silly p. But going back to the mean, sample proportion silly p is normally distributed if n is large. The true population mean of the random variable silly p is mean of silly p equals regular p.
So 0.4.
Right?
Sounds like a plan.
Or am I missing something?
Nope, I'm thinking you're tracking true. I mean, based off of what this shows, that makes sense.
Okay.
Do you disagree, Jordan?
No, it makes sense. I'm just, yeah.
Okay. Well, if 0.4 is the mean, then I have 9 right. If 0.4 is p, then
silly p is going to be 0.4.
Not silly p, regular p.
Well,
so we haven't got to 9, right? 9's the one we got to do the formula. Silly p is, that whole p parenthesis 1 minus p parenthesis over n square root thing.
The square root of that, yes.
Okay.
Where's the mean of p?
It's down in 3.2.2.
Wait, what's n? 24? Oh.
Yeah.
Okay, because, okay, wait, sorry. Sorry, I kind of zone out for a second when I'm reading.
No, you're fine, bro.
To find the mean of p, it says that the mean of p is equal to, silly p is equal to p when n is a large enough group, right?
Right.
But I don't think n is large enough. Or is it?
Yes, it is.
N is greater than 10.
Exactly.
Oh, is it 10? Oh.
Yeah.
So 8 is 0.4. Okay. I need to stop zoning out. Standard deviation then. Okay, we'll just punch that in.
Yeah, that's just the square root of p times 1 minus p over n.
Okay.
And I'm sorry, but what did you say it was again?
Yeah.
So it would be 0.4 times 1 minus 0.4 all over 24.
Right.
And so
0.01, right?
Well, you have to take the square root of 0.01.
Oh, you're correct. I forgot the square root thingy.
But it's still 0. It's 0.1.
Yeah.
Is that what you got, Jordan?
I'm punching it in right now.
Okay. always forget to do the square root. Square root. What do you want? Go away.
Okay, what did you get? I got 0.1.
Yeah, that's what we got too. Go away. Where's your bone? Go get your bone. Go.
Okay, we got
Go get it.
question 10. Did I miss something here? Oh, yeah, I did. Okay. Hold on. I might have just figured out my own mistake. It happens occasionally.
So to figure this one out, I just did x over n. So I did 35 over 100.
Correct, right. That's what I didn't read the question slowly, and
Okay.
that's what screws me up every time.
Okay. So I just got 0.35.
0.35.
That sound right to everybody?
Yeah, sure.
Yep.
Okay, so the standard deviation would be 0.35 minus 0.3.
Wait, hold on. Yeah, you were doing which one again? Standard dev?
Yeah.
Is that?
Oh, just kidding. I was reading the wrong one. Sorry. 0.3 times 1 minus 0.3 over...
Okay. Had me worried. I'm thinking I'm looking at the wrong formula. And
No, I was looking at the z-score one. Sorry. I wrote them all down. And
yeah, so did I, and that's why I'm like, wait a minute.
I know. Sorry, and I didn't label what they are, so I probably should do that right now.
Put it in a... I'm sorry.
Very good.
Um, 0.0021.
You have to take the square root of that.
Dang, David, I forget that every time. 0.045 or 46.
Yeah. That's what I got.
That square root thing is going to be the death of me.
I know, seriously.
So what did you get? Did you get 0.046?
Yeah.
And then the z-score equals to value minus mean.
Yeah.
So what's the value?
That is silly p, so it's 0.35.
Okay.
So 0.35 minus 0.3 over the standard deviation.
Minus the mean. Divided. And you got negative 12.28?
Not even close.
Wait, what?
So,
Put in 0.035.
yeah.
1.087.
That's what I got.
That's what I got. Okay, so the probability that Brittany gets at least 35 hits in her next 100 at-bats, isn't it just 35.00? Or do you have to plug in the z-score to the applet?
Yeah, I think we got to put the z-score into the thingamabob.
Okay.
So 1.087.
0.087.
What happens when you have parental?
Or, let's see.
And then you shade just the one to the left, right?
Ugh, I'm not sure.
Or do you do the middle and the left?
I'm not really sure. Isn't there something in here that shows that?
So for 13, are we doing the crazy equation where we do p minus p all on over that square root equation?
No, you just take the z-score and you plug it into the applet, and I think you only shade the left side.
Yeah, I think. Oh wait, no. I think it's only the right side, isn't it?
Well, either way, they're the same, so it doesn't matter.
So we're looking at 0.139.
Yeah.
Yep.
Yeah, she
Okay.
told us straight to our faces that she wanted to get this earned.
So for 14, I did 0.52, since that's p, times 1 minus 0.52 all over 2,000, and take the square root of that.
Yep, that's what I'm working right now.
Okay.
And you said 15 was the only one you didn't find out?
15 and 16.
Okay.
No, go away. Go away. Go. Go away. Get out of here. Go. Go. Naughty. What'd you guys get?
Working on it still.
Okay.
Sorry.
Did you
No, you're
get 0.011?
That's what I got.
All right.
Yep,
So
point
what
0.011.
Okay.
zero?
Now, this is what I was explaining to Lee.
Yeah.
Because, so for the z-score, you have to have silly p. But you can't find silly p without x. And I don't know what x is.
Okay, so we know that the p is the proportion, right?
Silly
If the sample
p. Silly p is sample proportion. Regular p is the mean population. I mean the population mean.
Okay.
Well, wait a second. If we
still have like another 6 months to a year, I would have thought it. But...
All right.
Is there any way to work backwards?
That's what I'm trying to think of. Yeah.
I don't know.
Their contract's up.
Because mean of silly p equals to p. I mean, if we know the mean of p and no.
No, that's not what I wanted.
Yeah, that's pretty tough. So,
I'm working on it. It's going to take me a second.
You're good.
Trying to find a way to do it here.
My husband's group met last night, and they didn't tell him, so they did it without him. And I was like, dang it! How am I supposed to know? What?
I got it.
How?
I got it.
How?
I'm an idiot. X is 0.48.
how do you know that?
Because in order to have a 1, if you 1 subtract 0.52, what's left over? 0.48. X is the other proportion.
Are you sure?
I'm positive.
So 0.48.
Yep. Well, that's what X is. So we put X into that little formula.
Right. Okay. So X divided by 2,000. Because that's what N is.
It's all cute theory, guys. We'll see if it's right.
So that would mean that silly p
Well, thanks for doing
is 0.000.
It's got to be right. It makes sense.
Good.
Oh, wait a minute. Hold on. I'm still working on this. Hold on. I think we're using the wrong formula. Because the standard deviation is actually going to be 0.52 times 0.48 over our sample size, and it's the square root of that.
What?
Hold on. I'm almost positive that I'm right.
Okay.
Oh, sorry. Just all still lines.
It's fine. Just make more noise.
I hope I'm right, but I think the answer is actually 0.011.
Well, that's the
That's
standard.
the standard deviation.
We're trying to find the z-score.
Oops, wrong formula. My bad.
Yes, you're right.
Let me flip over my piece of paper again and try that again. I'm looking for the z-score. Grab the wrong formula. I need to label these. All right, so.
Well, okay. Wait.
So wait a minute. Hold on. We're looking at z. You're looking for which again? The z-score or proportion?
What?
We're on 15, right? So we're looking for the z-score.
Right.
So where did you get the you need to know x to figure that out?
Because you need to know silly p, and you don't know silly p without knowing x, because you have to figure out what silly p is and then plug it into the z-score formula. So you have to find the proportion before you can find the z-score.
All right, so and we determined that, let's see, with p being, okay, so 0.48 minus 0.52. Crap. I swear I'm on the right track. I know I am. I'm just getting lost in the weeds. And we needed it was over standard dev, which we said was 0.011.
So. I don't think we need the x.
How not?
Can a z-score be a negative number?
Yes.
How about negative 3.636?
How'd you find that?
Okay, I may be on the wrong track again, but I'm going to go with it here.
Okay.
I still believe that X is 0.48 and P is 0.52. So if we take 48 minus 52 gives us 0.04 divided by the standard deviation of 0.011 comes out to that negative 3.636. I mean,
You guys, wait.
Done.
Yeah, for now. Okay.
Say we
I mean,
have to go with that because that beats my best guess.
now I'm looking on Google just to see if I can find any other references that may give a better manual than what we've got on it. But
Not that I don't trust you, Lee, because I totally do.
yeah, I don't trust me with this. I mean, my wife's in there laughing, but hey, man, I failed the midterm. I don't trust myself with this. I mean,
That's really funny.
You all have been unsure of yourselves through this whole thing. I just had to
Oh,
laugh.
wait.
I wasn't being exploitive.
I'll be the first one to tell you if I don't know something.
Okay, so they're going over 15 and 16.
So, what is the probability the survey results will show the candidate is losing, even though the true P is 0.52? I don't even understand that question.
The whole thing is 40 minutes long.
Okay. Okay, so for 15, they got negative 1.818,
I'm not sure if it's right.
but the first time they did their quiz, they got it wrong. But then they got 16 right. But I don't know how they get 16 right if you get 15 wrong, because you have to use the applet.
I don't know if 15 might be right. I don't know.
So 16 would be 0.035.
And they got 15.
And how do we know 16 is 0.035?
Because they got that one right.
Okay, but how did they get it? That's the question.
See, that's the thing I don't know.
That is weird.
Because you have to know the z-score to plug it into the applet to get 16. So I don't know. I don't know how they did that. Okay, I'm gonna submit and see what we got. So 7 is wrong, and 7 and 15 are wrong.
7 and 15.
Okay, well,
7 is wrong?
Yeah.
Impossible. Alright, fine, I'll do that. Okay, wait, let me submit mine and see if I got 7 right then. I just changed
What did you put?
1 second. Ah, how is that wrong?
What?
7.
13.34.
What did you put for 7?
13.34.
That was for 7?
Yeah, it's wrong, and I don't know how.
No,
What did you put for 7?
I haven't submitted yet because I'm still trying to figure out 16.
Oh.
15 and 16 actually.
No, duh, that's why.
Why?
Okay, just give me 1 second.
Okay.
I think it's 40.
What?
Yeah, 7 is 40.
And where do you get 40 from?
Yeah.
I only used the right-hand equation, but if it has to be equal to both, n times p is greater than 10. If p is equal to 1/4, 1/4 of 40 is 10. So in order to make that statement true, n has to be 40.
I'll buy that for $1.
Yeah, sure.
Then again, $1 doesn't make as much here in this country anymore.
Yeah, that's true.
I still don't understand where we botched up. I got to figure out the z-score thing. This is killing me.
Yeah, I have no
Can
idea.
I buy this later on? Hey,
So if we look at in the textbook from this week, 3.3.2, example, political elections.
Mm-hmm.
This is what we're trying to figure out, is the Z. Where did they come up with 0.5 for the silly P?
I don't know. Is that from the 50%?
Yeah.
So on the quiz then, would it be 0.35 for 35%? I mean, just kidding, I was looking at the wrong one. Would it be 0.5 because it's 50%? Because it could go either way?
Could be.
Because that's the only similarity that I am seeing.
Well, let me hold on. I'm trying to
Work
put
it
that
out.
into a formula here and
Okay.
work it out and all that fun crap. All right, so we said it was 0.5. I gotta go back over to this one, and it was. This thing keeps moving around on me. Okay. What was our sample size on this again?
2,000.
That's what I thought. All right.
Yeah.
Mm-hmm.
7 is 40.
Jordan, you were right. 7's 40.
Yes.
So 15 is just wrong on the quiz because they said there's no way they could have gotten 16 right if they had 15 wrong.
Did you hear that?
Yeah, I mean, it makes sense. I don't. Yeah.
So what did they get for 15?
They got negative 1.818. They tried it both ways. They tried it with and without the negative.
And it was the same?
They got it wrong both times.
Okay, that makes sense.
So we're just gonna email it, or maybe he'll change our scores for that if it really is
Yeah.
possible. 11 was 0.046, right?
Yeah.
All right, thank you.
You're welcome.
13 was that 1.39 or 0.139? 0.139.
Yeah, hold on, sorry. I didn't mean to change the subject, but 16, if 16 truly is 0.035, it absolutely has to be 1.818. Because
Right.
if you put it in the probability applet, it only fits.
Well, right, which is what we're saying. Like 15 is just wrong.
You put it in the probability applet again.
Okay.
Yeah.
And
So-
16 was 0.035. So
Yeah.
then all I should have to do here is just submit. Hold on, Jordan. Let me.
Can I see that?
7 is 40, and we are good to go. Crap, how did I get 15 wrong? Oh, that's right. That one's wrong. Never mind. It's been a long day. Okay. I'm content.
Okay.
Cool. So then again on Thursday night, or do we want to meet tomorrow night?
I can't meet tomorrow night. I'm seeing the tutor for
Oh, that's
SPSS
right.
tomorrow night.
Yeah, because you're going to need to like tutor us on SPSS.
Yeah.
All right, then I'll meet you guys here same time Thursday.
Yeah, that sounds good.
Yeah, we're
Cool. All right.
awesome.
I'll
Thanks,
talk to
guys.
y'all later.
Okay, see ya.
Good night. Bye.
You too.